you to know how to do the harder ones. So the formal definition of the derivative is exactly what we've been doing. The limit as h goes to 0. They've just replaced our a with a letter x, but just remember that it's just a letter, it's just a symbol. It can be a or x or p or q or whatever letter you like. So then we're learning this new notation, and we read this f prime of x. So I make it a little diagonal dash. Other people make it more like an apostrophe in English, but it really is supposed to be straight if you look carefully at the typed notation. So when we find the derivative at a particular point, then we're finding f prime of a is at a particular point. But f prime of x is a function that can be evaluated when x equals a. So it's actually a function, not just a number, because there's other things we can do with it that we're going to learn. So the process of finding or computing or calculating derivatives is called differentiation. Hardly anybody says that. They usually say find the derivative. And you'll see all these words, computing, calculating, so just be aware that they all mean do the same thing. Find the difference quotient, find the limit as h goes to 0. Then keep reminding yourself that the slope equals the rate of change. So the derivative equals the instantaneous rate of change equals the slope of the tangent line to the graph of a curve. So repeat, repeat, repeat. Okay, so then we have a picture here. It's just asking us to look at this graph. And first of all, it says, what value of the function is the largest? So that says, what's the highest value of y are you seeing? And then it's asking you, where does it occur? So to me, this looks like the highest y value. And so you'd say the answer to A is at x sub 5, that is where the function has its highest value. And then of the choices we're given, it looks to me like at x sub 4 is where the function has its lowest value. So then it's asking us about the derivative. So where is f prime of x smallest is saying what slope is smallest. So if you look at x1, the slope is positive. If you look at x2, it's positive, but smaller because it's not as steep. At x3, it's negative. So that's a possibility because a negative number is going to be smaller than either of those positive numbers. At x4 and x5, the slope is positive again. So at x3, that negative number slope is where f prime of x is the smallest because it's a negative number, whatever it is. So then it asks, where is f prime of x the closest to 0? And remember that a slope of 0 is a horizontal line. So right at this point, the slope is 0. So it looks to me like at x sub 2, it's the closest to 0. It's almost flat there, but not quite. Okay, so a couple more examples. Here is just changing the language and saying find f prime of x for each function. So we're going to keep doing what we've been doing and do f of a plus h. So we're going to have negative 4 a plus h quantity squared plus 11 times a plus h. Simplify that as much as you can. Aren't you glad we memorized a plus h quantity squared. And we're going to distribute the -4 to each and every term that comes after it in the parentheses. Then we're going to do the next step of f of a plus h minus f of a. So copy f of a plus h. Just be very patient. Take your time. Minus f of a is -4a squared plus 11a. So we're going to have -4a squared minus 8ah minus 4h squared plus 11a plus 11h plus 4a squared minus 11a. So yay, the 11a's cancel and the 4a squareds cancel. So I'm going to factor out h. Then I'm going to do the divide by h step. So I'm going to have -8a minus 4h plus 11. Then I'm going to do the limit as h goes to 0. And get -8a plus 11. Well, this would be f prime of a. So we're going to change it to f prime of x simply by replacing the a with an x. So this is the answer to what is f prime of x. And then find f prime of 2. So make sure and use the notation like I'm demonstrating for you. And you're going to get -5. So this says the slope of the tangent line to this graph when x is 2 is -5. So the graph is going downhill at this point. Okay, and then we have an example here where it's just starting to get used to thinking about the meaning of these things. So a credit card statement has information about how long it will take to pay off the card if you only make minimum payments, and how long it will take if you make larger payments. So it's explaining this function m of p, where m is months to pay off. If you make a monthly payment of p dollars is the monthly payment. So it says explain what m of 25 equals 50 means. So the p is the number inside the parentheses. So if $25 monthly payments are made, it will take 50 months to pay off. And then it says, would you expect m prime of p to be positive, negative, or 0? So that's talking about the rate of change. So as p gets bigger, I think you would expect the number of months to get smaller. So you'd think as p gets bigger, you'd expect the number of months to get smaller. So that would give me a negative slope, and the derivative tells you about the slope of the tangent line. So the number of months to pay off should decrease as the monthly payment goes up. This is what are the units for m prime of p? It's slope. So it's going to be the same units as slope, which was units of y. So months to pay off per dollar of monthly payment. Units of y per units of x. So it's a months to pay off per dollar of monthly payment. So M prime of 25 means if the monthly payment is $25, the number of months to pay off is decreasing by 3 months per dollar of payment. So try not to think too hard about it, but look at where the pieces go. Where do the words that match up with Y go? Where do the words that match up with X go? So do lots of examples and we can talk more about this. And please ask questions if you have them. It's really hard to translate a lecture where I would show you lots of desmos